Hi, in the previous videos we have been talking about breadth-first search and the applications of breadth-first search focusing on the web crawler, and now in this video we are going to talk about the so-called depth-first search, which is a bit more memory friendly. So if you are short of memory, then you have to use depth-first search in order to traverse a graph. But if you want to traverse the neighborhood, the local environment of a given point, then you definitely have to use breadth-first search, because depth-first search is going to go as far as possible from the given point. So I'm going to create a new package, depth-first search. And basically we are going to have three classes: the vertex, then we are going to have the DFS, and the application from where we are going to test our application. The vertex is quite straightforward. We are going to have a private string name. We are going to have strings on the vertices. Then we are going to have Boolean variables to be able to track whether we have visited a given vertex or not. And of course we have to store a reference to the neighbors. So the vertex neighbors list or adjacencies list, whatever, neighbor list. In the vertex constructor we are going to have a string name. So this dot name is equal to the name, and basically we instantiate this neighbor list. It's going to be a new array list. Okay, Ctrl-Shift-O to import the java.util.list. I'm going to override the toString method, and I'm just going to return this.name. Okay. I'm going to generate getters and setters for the name, the neighbor list, and the visited. And basically I'm going to have another method, the public void add neighbor. We are going to add vertices, and basically we just have to add this vertex to the neighbor list. So neighbor list.add.vertex. Ctrl-Shift-F to auto format, and that's all about the vertex method. The depth-first search method is going to be very similar to that of the breadth-first search. First I'm going to have a public void DFS. It's going to get a list of vertices, for example vertex list. And let's consider the fact that we have several distinct components, so-called clusters, and we would like to traverse all the vertices, all the nodes in the graph. So that's why we have to iterate through all the vertices in this vertex list. And we have to check whether this v vertex is visited or not. And if it's not visited, then of course we have to set it to visited. And then we have to call another method, for example DFS with stack with this v vertex, and we have to create this method. And of course we have to import this list. So why do we need this for loop? Because let's consider the fact that we have two clusters, the 1, 2, 3 and the 4, 5, 6. And okay, we would like to traverse the whole graph, no matter that it has several distinct components. We would like to visit each and every vertex of the graph. So okay, we have two clusters and we would like to traverse all the clusters. So we start at the first one. Basically this is the root vertex. We start at a given vertex, and with the help of this vertex we are able to visit every single vertex in this given cluster. We visit the neighbor 3, then we visit the neighbor 2. Okay, but we haven't visited all the vertices, the nodes, so we have to continue. So that's why we have that for loop, and we consider every single vertex in the vertex list. Okay, if we are here in this cluster, we are able to visit all the neighbors. So at the end we are going to visit all the vertices in the graph. So basically that's why we need this for loop. And this for loop is going to call this DFS with stack. Just to be clear, if we have a single connected graph, which means that it contains a single cluster, then of course we don't need a for loop. We do need a for loop when we have several clusters and we want to visit every vertex. So here we are going to have a stack. The implementation is going to be very similar to that of the breadth-first search, but instead of using queue as an abstract data type, we are going to use a stack. And the stack has a LIFO structure. The last item we have inserted will be the first item we take out. So last in, first out. This is why it is called LIFO structure. So I'm going to have a stack, or I'm going to define it as a private variable. Private stack, of course we are going to store vertices stack. In the constructor I'm going to instantiate it. So this dot stack is equal to a new stack. Okay. And here I'm just going to have a v vertex. I'm going to rename it to root vertex. And basically at the beginning I'm going to add this root to the stack. So add the root vertex. Then because we have visited this root vertex already, I'm going to set visited true. And this while loop is going to be very similar to the implementation of the breadth-first search. So while the stack is not empty, I'm going to get the actual vertex from the stack. So this dot stack dot pop. I'm going to print it out to the console. So system out println print and actual vertex plus some spacing. And because this vertex has the toString method, because we have override the toString method, that's why it's going to be called and the name is going to be printed out. Okay, and after that we have to visit the neighbors of this actual vertex. So actual vertex dot get neighbor list. And basically if we haven't visited the v, so if v dot is visited is equal to false, it means that we haven't visited this vertex, so we set it to visited. And we are going to insert it to the stack. So push and the v. It is very similar to the implementation of the breadth-first search. Okay, so let's see whether it's working fine or not. I'm going to have a main method. In the main method I'm going to have the vertex v1, for example, equal to a new vertex with the string 1. I'm going to have the 2, 3, 4, 5, 2, 3, 4, and 5, 2, 3, 4, and 5. I'm going to have a list of vertices. The list is equal to a new array list. Okay, I'm going to import the java.util.list. The v1 is add neighbor. We are going to add the neighbor the v2. We are going to add the neighbor v3. Then the v2 will have the neighbor v4 and the v4 and the v4 will have the neighbor v5. Okay, then we have to add these vertices to the list. So the vertex 1, and I'm going to add the vertex 2, 3, 4, and 5. So 2, 3, 4, and 5. I'm going to have the DFS equal to a new DFS. And let's see whether this depth-first search method with the list is going to yield the good solution or not. So if I run it, it's going to print out 1, 3, 4, 5, 2. And basically, it is working fine. Because if you test this algorithm on a huge graph, it's going to be clear that what's the difference between depth first search and breadth first search. Depth first search is going to go as long as possible on a single branch. And 1, 3, 4, 5 suggests this. And 2 is the another children of the V1, so that's why it's going to be visited in the last iteration. If we were dealing with a breadth first search, we would visit the first vertex, V1, then the neighbors of the V1, so V2 and V3. But here, this is depth first search. We are not going to visit the other children, we are going to visit the child of 3, then the child of 4, the 5, and so on. And at last we are going to visit the other children of the 1. So this is the main difference between depth first search and breadth first search. And this is how we implement depth first search with the help of the stack. It's very important that if we are dealing with breadth first search, we have to use the Q abstract data type. If we are dealing with the depth first search, we have to use stack as the abstract data type. It is a very, very common interview question, so definitely worth understanding. Thanks for watching.